Get started. Welcome everyone. We are particularly glad today to have with us in our Kusarigama project Morane Otilia Gruenpeter.
Welcome everyone. We are particularly glad to...
A minute, okay. As I told, today we have with us Morane Otilia Gruenpeter, software engineer and metadata specialist at Software Heritage at the Institut National de Recherche en Sciences and Technology du Numérique in Paris. We are really pleased that Morane has accepted our invitation to participate in this event, actually at the final event of our project. As you know, the name of our initiative, Kusarigama, is the name of a Japanese weapon that samurai used in different ways. This weapon was used both in hand-to-hand and remote fighting. In naming our initiative, we wanted to be inspired by this versatility. The Kusarigama project is part of a bigger research project of the University of Pisa, coordinated by Professor Adriano Fabris. And at the end of this exciting journey, I want to thank him for his active contribution to the success of these events. Ethics today needs versatile conceptual tools because it must refer from time to time to a constantly changing world. This adaptation to context and practices in some way ask us to go beyond the traditional approach that conceives philosophical theories and practices onto different fronts. During the Kusarigama meetings, we have increasingly acquired the awareness that there is a deep connection between these aspects, theories and practices. We can identify probably a new configuration for philosophy and ethics in particular, if we are able to listen to the context and to effectively dialogue with the experts who operate in the context. For this reason, today I am very grateful to Morane for accepting our invitation because it allows us to go a step further. So welcome, Morane, and now I am grateful to Professor Paolo Ferragina, who is Pro-Rector of the University of Pisa, and invite him to give his welcome address. Please, Paolo.
So, thanks, Giovanni. Yes, it's my pleasure to participate to this event. Also, I was present here for the other one before with the journalists from Sky TG24, so that was a private TV in Italy. And as I said before, when we were before starting this lecture, I'm not so tied to philosophy. My background is fully on the scientific side, but it was a surprise for me when Giovanni proposed to just be part of this event, because I have a connection with the Software Heritage project, because I know very well Roberto Di Cosmo. And actually there was a link about this project from a computer science point of view, because my research field is about graphs and compression of graphs. And so Roberto was asking me to give a contribution in this project by just making this huge graph of software, let's say, be processed by algorithms. And the current size is so huge that it's very difficult. And so he wanted me to be involved, and I started to read this stuff. But I would say now, unfortunately, I started to get in touch with this duty of vice rectorship that is absorbing me too much from a political side and organization stuff. So my research contribution is very tiny, but still I'm let's say, linked to research because I like a lot. It's my life. And so I consider vice rectorship just as a side work every day, even if it takes 99% of my time. And so I'm pleased. So thanks very much to Morane. I will follow his, let's say, his speech with much interest, and I make my questions that will be a questions from a computer scientist. So no deep stuff from a philosophical point of view. Okay, thanks very much.
Thanks, Paolo. Please, Morane.
Thank you, Giovanni. I am going to share my screen. Just a moment. And I'm going to start. So hi, everyone. Thank you for joining me in this and joining us all in this discussion today. I'm going to talk about software preservation, which is a very specific part in software engineering, right? Software can be a very big question, but here today we'll be looking at software heritage, the project, and software preservation in general, and ask ourselves, does software preservation have an ethical impact on society? I don't have the answer for you today, but that's the reason we have this discussion, right? So I'm Morane Gruenpeter. I'm a software engineer and metadata specialist at the Research Center with the Software Heritage team. And before we start, I will do a small introduction of myself. I haven't started as a software engineer. I was a harpist before, I was a musician, but the software engineering took my life away and really impacted what I'm doing today after software engineering studies. I'm now with the Software Heritage team for 3 years now and enjoying every minute. I'm also part of different working groups about open science and digital preservation, which I won't detail here, some interesting working groups. And the first thing that I wanted to see with you today is our goals. We will be trying to look at terminology around software and source code. We will visit a few elements to grasp the recent and not so recent evolutions in software development. Look around at software as a key to view society and review some initiatives working on software preservation, specifically the Software Heritage Project. So what is software? Software is all around that, right? I've put down here 2 great examples and interesting quotes. One from '69 from the Apollo 11 project, where Margaret Hamilton is standing next to all the code printed, which are, well, as you see, it's a very high pile of source code. And then saying, when I first got into it, nobody knew what it was that we were doing. It was like the Wild West. And we got very far from there, even though it was not so long ago. Next example here is it's Tim Berners-Lee saying in 2013, when somebody has learned how to program a computer, you're joining a group of people who can do incredible things. They can make the computer do anything they can imagine. So for the ones of you that people here that don't know, Tim Berners-Lee has invented the World Wide Web in '89. It was at the CERN Research Center. It was on the next machine. So what is software? We can look at that in a simplistic way, where the users see the user interface, right? And a lot of magic happening behind that. And there's another way to look at it, where the user interface is just a window to the logic and the data, and especially the logic of the data transformation that is inside that software. If we go look at Encyclopedia Britannica's definition, we have instructions that tell the computer what to do. software comprises the entire set of program procedures and routines associated with the operation of a computer system. So that was a term coined to differentiate from hardware. When looking at that, we don't have two main aspects of what we can consider as software. Software can be a concept, it can be the project and the entity and the entire creators and the community around that. And it is also an artifact. So the definition is more about the artifact that is represented as the binaries, which are adapted and different for each environment. And there's the source code for each one of the version of the software project. So today, I'm going to focus the source code because as software heritage, we do preserve specifically the source code. So why do I say that I will focus the source code? And is the source code software? My answer is that it is the software, but people, and specifically users that don't understand software, that might not look at software source code as the software and only the thing that is working, the one with the magic, as the software. But I'm here to convince you otherwise, that the knowledge is in the source code. So now, to go to that, I'm going to explain a few aspects about that, about why the knowledge is in the source code. From the GPL license, the source code for work means the preferred form of the work for making modifications to it, because with the binary, you cannot go ahead and modify the software. Well, you can try, because here I'm going to show you an example of an excerpt of a binary. That's what the machine can read that. I'm not, I'm a software engineer. I cannot read that. I might be later, a few decades ago, maybe people learned how to go and change the binary, but I don't know how to do it. But when I go to the source code, when I look at this text, and when you look at this text, you might be much more inclined to change and to modify this part that is printing hello world. As you can see here, you have this function that you can change and say bonjour le monde, for example. Software source code is special. It must be written for people to read and only incidentally for machines to execute. That is a nice quote from Harold Abelson. It evolves over time because projects may last decades, and the development history is key to its understanding. And we need to understand how complex software can be. It is constituted from millions of lines of code and might be aggregation of a large web of dependencies. In the picture here on the right, you can see how entangled it is. Well, one part of one software can depend on a web of dependencies, and there is a sophisticated developer communities around it that develop software. So as I said, it is human readable and executable knowledge. Here, an example directly from the Software Heritage Archive. So that's a print screen from that archive. It is the Apollo 11 project, and it is a single file from that project. And here are marked a set of lines where you can see only comments. Below the comments, there's also the source code, but that's also interesting. In the source code, you can include comments, include information, include things that people will be able to read when it's looking at the source code. Even if it is yourself 6 months later, it's a key to understand the thing that you have written. And here there's really nice comment that you all must know better than me since it's in Latin, which tells us do not touch, right? So a think more. So now that we have accepted that the source code is interesting, it is complex, but it's a window really to the mind of the designer. And something else that is important that I've noted is the development history, because a source code is something that evolves over time and changes a lot. And for that, version control systems have been created to record that changes in the source code and to allow different operations to happen, which are here detailed, but I won't go over these operations. It is an essential tool for software development. And if we look at the 3 last decades, or maybe four last decades now, we have in the 80s, the local version control systems with RCS that evolved into the centralized version control systems with CVS and Subversion, where different files could change in different machines, but the version control system was still centralized as one, and you couldn't do modification like we do today with distributed version control systems, which are the most popular now with Git, Mercurial, and Bazaar. And Software Heritage actually launched in 2016, trying to capture all the source code and all the history of development in all the different forms of version control systems. So to accept this heterogenic situation, we have this very large tree that capture this information, the history and the source code. So to look at just a second about the adoption of the newest version control systems, we see that Git is the most popular system development version control version, and this is in numbers, and we did use that to create we do use that in the Software Heritage Archive. So to continue, now that I've given you some keys about the Software Heritage Archive, let's see what it is all about. So Software Heritage has the mission to collect, preserve, and share all software source code, enabling better software and better science for all, but also just better society, I believe. It is here to create a reference catalog where we can find and reference all software source code from different origins. So even different development history systems, but that were source code that was developed on those different platforms using different development systems. Then we have the Universal Archive to preserve all software source code and make sure that disaster won't happen. Well, the disaster can happen, but then we need to know that the source code, then the knowledge that is captured in the source code is kept somewhere, right? And a research infrastructure to enable analysis of all software source code, so we can enable advancement in science. The key principles of software heritage are to be a universal archive for different disciplines and different parts of society, for cultural heritage, for industry, for research, and for education. And today, or at least in October 2020, we are at 140 million projects and almost 9 billion source files in the Software Heritage Archive. We have growing support. Even today, this sponsoring slide is out of date because we have recently got the CNRS sponsorship at the platinum level, but we have many sponsors that see this vision of having software source code archive. We have the UNESCO that sees the vision also having this software, the source code archive, and many other initiatives in software development. The software development community are sharing this vision as well. We are at a turning point. Looking at the past, a lot of old software is misplaced, lost, or behind barriers. So much software is behind barriers. And most founding fathers are still here and willing to share their knowledge, and even maybe sharing the source code. It is urgent to collect that knowledge, and we have only a few years left to have this knowledge. Looking at the future, software development and use skyrockets, more programmers and more code. It is essential to provide a universal platform for all the future software source code. It is urgent to take action now. And so we are getting to the part talking about software preservation and the Paris Call. In November 2018, at the UNESCO headquarters, many experts signed an engagement for software source code preservation, recognize software source code as a precious asset of humankind, support the development of shared infrastructures, and foster international collaboration to build a common framework. Some of the quotes from the Paris Call call for how software source code is crucial and captures human civilization, how raising an awareness of the importance of source code among decision makers, recognizing software creators and the contribution of women and minorities to digital innovation is important. Considering that documents produced and preserved over time in all their analog and digital forms are primary means of knowledge creation and expression. And this has an impact on all areas of humanity's civilization and its further progress. Considering at the same time that the preservation of and long-term accessibility to documentary heritage underpins fundamental freedoms of opinion, expression, and information as human rights. There are some strategies are there for archiving, and a year ago there was this incredible join of forces with GitHub for the creation of the GitHub Arctic Vault. But not only GitHub, these initiatives here on the left join forces to preserve this humankind source code. It is a testament to the importance of source code. It is a multi-partner strategies, and there's a range of storage solutions for real-time and not real-time. So the GitHub Arctic Vault, I don't know if you know this project, has had the intention, and now they did proceed with that, to print source code on film, like here in this image. And with that, having the source code that was in GitHub on the 2nd of February 2020, this source code was put into the Arctic Vault to stay there and be preserved for the next 100 years, but not to have access to it. We have the Internet Archive, which is I don't know if you know that project, but it's very important to know that web pages can be archived on the Wayback Machine of the Internet Archive. And this is also part of the Internet preservation. They do not preserve source code, but they do preserve some parts of software binaries that are actually possible. You can go to the site and emulate those software of games. And with that, I'm going to finish with the software heritage acquisition process, which was created with the PISA University. So that's why I've picked up to show you a little bit about this acquisition process to rescue legacy software, which was written a long time ago, create the code and reconstruct the development history, because it is important that we keep that information, the history of the versions between source code versions and collecting metadata and illustrating it with dedicated presentation. So the acquisition process, first developed by the University of Pisa and Software Heritage under the looking eye of UNESCO. They developed these 4 phases of workflow where software is collected, curated, and then archived first on GitHub and then pushed to Software Heritage. So it's not archived in GitHub, but it's archived in Software Heritage. And then the last part was to present this software that was acquired. One example is the Taumuse example, written in 1972 by a group led by the late Pietro Grossi. Here you have an excerpt of the source code, the printed source code, and this was put in the GitHub repository like that, and with some kind of metadata to curate the source code that was deposited. Then the version history was also created with the correct author and the person contributing these commits. Then with the safe code, now the software, the legacy software that was collected was sent to Software Heritage. And now it can be found in Software Heritage and identified with a Software Heritage identifier, which I didn't really told you about here today, but I think that I told you a lot of things and I don't want to mix you up with anything. So just know that this legacy software is now safely saved in Software Heritage. And now we come to the final 2 slides that I have for you. The first one is the ethical charter, the Software Heritage ethical charter for using the archive data that might launch our discussion. The main subsection in this ethical charter is to avoid harm, to protect personal data, avoid useless copies. I think that is one of the reasons Paolo Roberto has contacted you to avoid useless copies and create this data structure that uses the best way to not have useless copies of the same data. Care about derived data is the last one in this ethical charter. Then we have another ethical charter for mirrors. Mirrors are Software Heritage instances that are put in place in different research centers or universities that are not R-based, so that if something happens to the Software Heritage in France, the Software Heritage in the INRIA Research Center, we have a backup in different places. At the moment, it's still it's not in place, but we have the ethical charter for that project, and we hopefully will have soon a few mirrors on different continents even to secure all the data that is in Software Heritage. So here also avoid harm, protect personal data, maintain coherent terms of use, ensure fair and non-discriminatory access, and foster collaboration. And the last thing to tell you is that software preservation and ethics has many aspects to look and to discuss. And these are some of the discussion topics that Giovanni has given me today, that we can continue this presentation with. And I'm going to just move to the last one to thank you all for listening. I'm open to answer all your questions by email or here now, and to acknowledge Roberto Di Cosmo's work as the founder and director of Software Heritage, and his supervision of my work as a research fellow, and to Lea Gruenpeter, which helped me a lot to understand how ethics and software preservation have something in common, because to tell you the truth, I didn't know that we should talk about software preservation today. So yes, I'm going back to the last slide to open up this discussion.
Oh, very well. Many thanks, dear Morane. Very many thanks. Congratulations for the very clear presentation. I hope that this will be really the beginning of a collaboration, because we are really interested in these topics. So I would like to ask Professor Ferragina if he has some initial remarks. We already have many questions I see in the chat.
Yes, I just two very fast observations so to leave the scene to the students. The first one is I took some notes about the phrase on programs must be written for people to read. Now, this phrase nowadays seems very tough to reach with with artificial intelligence, because one of the main things is actually explainability, and because they are not easy to read, actually, the results, not just the code. And this is something very crucial, okay? So actually preserving the code, making the code available to others, as you have written in the first point, is transparency is one of the first issue, okay? It's very important. And the second one was about biasing, because transparency, most of the time people, at least in Italy, I don't know, in other place, politicians try to say, is the algorithm, okay? Who knows? Is the algorithm that decided this? Is the algorithm that has done this? So assigning responsibility to the algorithm, in some sense, is a sort of saying that is correct, no? But the algorithms up to now are written by humans. Until today, at least up to today, are written by humans. So who is writing code is also a responsibility, an ethical responsibility. As I've said to Giovanni when we met in computer science course in the master degree, we have a course on ethics. We started to have a course on ethics that I think is one of the first in Italy, because we believe that is fundamental. So nobody can, in some sense, neglect or consider less important the role that a computer scientist can do. If I look to myself 20 or 30 years ago when I was a PhD student, it seemed that what I was doing was so much technical and no impact to the society, just an impact for banks or some counting stuff. Nowadays, algorithms are in every place. And so since they are in every place and they impact on the life of people, they have an ethical impact. So I think that we cannot manage by ourselves, because we are very ignorant, and actually staying in front of a computer makes you more and more ignorant of everything and very not much open to discussion, or at least to go deep into the social impact. We are trying to stimulate our students to this. I'm not saying that they will become philosophers, of course, but they can start to have a language that allows them to have warnings in their mind and possibly be able to interact with philosophers as they are doing now with biologists or medical doctors or whatever. So thanks for this picture about the project, which I think is in the beginning, but is a lot of, let's say, ambitions with a lot of contributions. And also what is interesting is that it's a European project, which is very important, because underlies more and more what is the importance of ethics for us, probably more than from people on the other part of the ocean, or even on the other part of the continent, if we look to the east part. And so I leave to the student, because I think it's interesting to see and to hear their point of view.
Okay, thanks, Paolo. I ask Morane if she wants to answer.
just a quick remark. I completely agree that research engineers or engineers that are students that don't have enough information about the impact of the things that they are writing, and somehow by archiving it and making it accessible and shared, it's in my opinion a guarantee of better, well, a more constructed thought where it comes to publishing the software source code. So it might not prevent everything, but it is a step forward into more, maybe more ethical operations.
Okay, so we have different several questions, but I would like to start with a question of mine. Listen, Morane, I was really struck by, during your lecture, by the issue of complexity connected to software heritage. My question is, does this mean that on the software heritage side, specialists from different disciplines work together?
Yes. So yes, specialists from the different disciplines do work together, and we have some consultation of larger communities when it comes to the archive. There's an advisory board that is constructed from different researchers, and also all the source code itself is open and transparent. I'm not sure it might answer that. About the philosophers, right? Is your question more about if the more people from the humanities are involved? So I don't think so. I think that it might be a good mention that we need more disciplines to be included in this discussion.
Okay, many thanks. So first questions from students. Mattia.
First of all, thanks for coming and for your speech. And I want to ask a very straightforward question, because you as Software Heritage claim that software is essentially culture. So why do you claim so? And how do you think we need to frame the software, or for extent also technology culture relationship? And since you are talking to an audience made of philosophers, why should we care about software? Thank you.
That's a good question. Yes. Well, you should care about software, but like software should care about culture, culture should care about software, right? So why do we include its cultural heritage? It's more about the digital preservation side, because there's a lot of communities working about digital preservation, preserving whatever is digital, which can have a cultural impact, right? Like arts that are digital, or even films are in a digital form, and everything that is digital at the end is read by a machine and transmitted to you with software. So software is really, well, there's the part that the software is a tool accessing cultural heritage in digital format, but it is not only the tool, it's also the thing that capture the knowledge, the human thought. And even if someone that is not a software engineer, it might be difficult to capture how this knowledge is in the software. It is important to understand that the tool that you use was made from some source code that was written by someone. So like preserving a piece of textbook, or a piece of just a literature book, a science fiction book, or something that will give you some knowledge about what happened and what was written at that time. This is the same with software. Software was written by people. The people that written software in the 80s or in the 70s didn't write it the same way that we are writing it today. So there's some kind of evolution that is cultural, and people that are not involved in software should have some vision of that that part of what's happening in the world, right?
Okay, thanks, Morane. Next question, Salvatore.
Yeah, good morning. Thank you so much for your speech. It was really interesting. And thank you so much because you've spoken about humankind. And I read on your site, yeah, on the Software Heritage website, that one of your purposes is improving the quality of life. So we are basing the quality of life on the source code. But this marks radically the difference between the instrument for using the source code and who has not the instrument. So this is a way this is a way to radicalize the difference between who has not the possibility of living a good life. So it's a question about the digital divide. Thank you so much.
Thank you. So there's two, I feel that there's two aspects to your question: the living a good life and using the software, the instrument to having a good life, right? Because improving life would be, with preserving software, would be if there is some kind of disaster. A small disaster can be just a loss of the web pages where the software, the public software source code was published. The bigger disaster would be to lose a lot of software just because we have lost the source code. And then improving life will come as an answer to restoring that lost source code that is in use and is instrumentalized by society for software as a tool, as a software tool. I hope that answers your question.
Yes, sure.
Thank you so much. Thank you so much.
Giovanni, sorry. I think that there is another issue. I don't know how much the students know is related to the impact of software and codes on justice. So more and more people are talking about predictive justice. They are softwares that actually in the US, and fortunately not in Italy, are establishing if a person, how much a person has to be condemned, depending on some parameters that are really ridiculous. And in these cases, it has been shown a lot of biasing because they are based on artificial intelligence. And the examples that have been given to these softwares have been proven to be strongly biased, for example, to the color of the skin or other, say, country of born. And clearly this is a big and is crucial issue in terms of ethics and life and society, because it depends on the examples that they are giving. So for example, if you have the black skin, and even if you did exactly the same as a white person, the software will say that you deserve, let's say, 8 years instead of 2 years of, let's say, of jail. And so this is, in this sense, in some, probably Morane was meaning the fact that he's impacting the humankind. Because it's the first time in the human history, I think, that these tools are, in some sense, are active in deciding our life. Before, there was the human that was, in some sense, piloting these artifacts. You think about knife or guns, there was always a human doing something. In this case, these systems are becoming, in some sense, independent, and they are making judgments, they are making things. So they are becoming, I don't know, I'm not a proper language to express, but they are becoming individuals in some sense. So they can do something. So, and in this sense, of course, this is a starting project, but I think that the discussion of the software is getting more and more sophisticated. It must be a discussion that must enter for sure at the level of philosophers and other people in the Italian discussion. Because for now, as I'm participating to meetings, I participated actually on predictive justice just 1 week ago. And in the roundtable, there were just the computer scientists and people from law and lawyers. So lawyers think about the speed of justice. Computer scientists think about how nice is the artificial intelligence. And actually, I was the only one to think about human and say, what is the danger about using our tools? So sorry to intervene in this discussion, but just changing a little bit the point of view.
Sure. Thanks, Paolo, for this clarification. Actually, there is a gap to fill on this level. I don't know if Morane wants to add something.
I want just to add, I completely agree. And I think that this aspect should be included in every company and every research center that does do software engineering. And here today, as we look at the software preservation point of view, it might be too late, right? Because it's behind the development. Well, the development already happened. But by preserving the software source code, we do have access to what was done in the decision making that is taken inside the code and the algorithm. So sometimes I agree also that it is impossible to read or very difficult to read, but it is much more difficult to understand a binary than to understand the source code. And if the source code is written properly, and if there are mechanisms in place to ensure that the documentation of the software and that the software itself is properly described with metadata, we do have access to this information, and we know where's the fault. So even if we are just coming after the development as the part where we preserve the already developed software, we give access to this information which need to be kept somewhere and should be available.
Sure. Thanks, Morane. Next question, Simone.
Yes, hi, Morane. First of all, thank you for being with us and for your speech. And I'd have a question that is linked to what Professor Faragina said before, and that is the problem of the decisions and the choices that are taken behind a software, behind a source code. In your opinion, as your goal is the goal of software heritage is to preserve software without any form of censorship, without any form of preliminary selection, how can you avoid to collect virtually unethical codes? In your opinion, a specific, maybe an institutional subject could guarantee the fairness of collected codes. I'm referring, for example, to an ethics committee, a committee which could be constituted also by philosophers, for example.
First, I'm very surprised from your question, but I want it's a great question and a great idea to do that. I would say that choosing is the ethical question. So you have put down a remark that we don't do censorships, and you're right, we are not. We don't choose the source code that we collect. We have chosen, but that's a technical decision of the forges that we did collect first and the ones that we are starting to collect now. But that's only a technical question of which is more popular and which will be next. And there are still public code out there that isn't archived, not because we don't want to archive it, but just because we are just 10 people on the team, and it's difficult to have everything from different sources, which is written, which is differently accessible. Well, there are different mechanisms to access it, so it needs more work, so we'll have everything. But the idea for software heritage is to have everything and not to decide if this is a good software in the terms of ethical software, or is it a good software in the terms of technically, functionally good software. I think that one of the ideas behind software heritage is to present facts. This is a fact that the software was developed at this time, at this place, at this origin, and we show you the source code that was there for your judgment and not for software heritage judgment of what is to be published.
Okay, thanks, Morane. Next question, Margaret, who is writing her final dissertation on cybersecurity.
Good morning. First of all, thank you for being with us today and for the speech. I am undecided on which question to ask, but are there any reason to attack the Software Heritage Archive? Has the archive ever been in danger? And does the archive need cybersecurity?
So, like everywhere else, everything can be attacked, right? So it should be kept safe, not to for your first question, is there a reason to attack software heritage? I don't believe people should have the idea to attack software heritage, but like everything that you don't know why people do things, it might be attacked. And so we do take steps to secure the archive, and also this putting in place mirrors of the same archives on different continents in different research centers is one of the solutions we take to preserve, to save the archive. So if one is attacked from the cybersecurity angle, or even one is put down in flames, right? That's also possible. That the information is not lost. So for now, we do have different servers that do duplicate the same data in different places, so it will be safer. And if one is attacked, we have a fallback. But there's a long-term strategy to prevent these attacks and any other disaster.
Very well, many thanks, Morane. Next question, Roberto.
Hi, good morning, Morane. Thanks for your speech. It was really interesting. My question is really short. How software heritage can help copyrighted material, also in relation with the open source software used, for example, for illegal exchanges or of copyrighted material? So also this kind of software can be preserved. Thanks.
Okay, so you're talking about the software that allows exchanges of copyrighted materials, not that the software itself is copyrighted. So for the software that is copyrighted, for now, it's not preserved in software heritage because it's not publicly available. And even if on the long term we want to have also this software preserved, it's not now in the immediate roadmap. For the other type of the ethical question, if we do accept this type of software, as I said before, we do not distinguish good or bad software. So we do preserve anything that is publicly available. With this notion of having it transparent is a key to knowing what is out there in society, in software engineering. So this doesn't mean that having it public or preserved makes it easier to do copyright fraud, because there's a person that will need to have, they will need to get the source code and compile the source code and do actions with this preserved copy to do illegal things. So in some way, as I stated before, we accept everything that is publicly available and existing without any interference with that procedure, and we not exclude things that are that might do harmful, that software itself is harmful. With that in mind, we do have the possibility to get takedown notices for specific software, and with that we delete this software if it happens that someone shows that the software is copyrighted, not the one that you mentioned, the one that transfer copyright material. But it can be also a question to have this takedown. But I'm not sure that's an intention that we should be having, because if we are going to try to search all the source code that is harmful in some way and say that it didn't exist by deleting it from the archive, it's like saying that Mein Kampf didn't exist and that the book shouldn't be should not be preserved anywhere, and for the reference, it's Hitler's Mein Kampf. So do we preserve only things that are in a sense of good to the society? I'm not sure I'm ready to answer that, if we need to delete all the things that we now consider as harmful.
Okay, thanks, Morane. Before the next question, it seems to me that Paolo should leave the meeting because another one starts for him. Thanks for joining us, Paolo.
Thanks very much to your invitation. And also, it's very nice. I make a comment which is not related to this let's say, to this meeting, but as a professor, I see that many students are taking, let's say, keeping open the camera, which is not common on our, let's say, on our side as computer scientists, because most of my lectures are on a totally blank and blind desktop, and has made my lecture a sort of not human lectures. But looking the students in their eyes is fundamental. At least it gives us more motivation to continue, okay, teaching and even because you understand what's going on, mainly.
I can ensure that we'll continue to work in this way. Also because we students of applied IT course are the best students we have, so.
So I think that we have to stimulate this interdisciplinary discussion also in the University of Pisa, inside and not only outside. And so thanks very much for the invitation. Please, Morane, say bye to Roberto from my side. And also thanks very much again. Bye.
Ciao, Paolo. Thanks.
Ciao.
Thanks.
Thank you.
Well, next question, Lucia.
Good afternoon. Thank you so much for your speech. I have some questions. One is, how does physical or offline problems of legacy, how does them influence the ethical chart about mirrors? And the other question is a kind of curiosity. I was wondering if there were some kind of blockchain models implemented in control systems, because actually blockchain is not just for money, and Bitcoin is a model about information technologies, and I was curious about it. Thank you.
Thank you for your question. So I will answer the second one before the first one. Exactly, yes, but I didn't put any slides about that, about the blockchain that creates the development history and actually the data structure, because I thought that we are not very technical on this discussion, so we shouldn't. I didn't input any information about how it is done. I invite you to go to our archive, and there are some publications that do talk about that, specifically on the software heritage identifier, which is a hash, and this hash is called a SWID. It is the thing that we use to identify each one of the artifacts in the software heritage archive, and it is built like a blockchain. So it's exactly as you said, it's not only about cybersecurity. And if you are interested in that, there's two publications about these identifiers that might be in interest for you. And for your first question about the offline legacy software, so as I've shown you on the slide, there's something that was more printed or even written down. So this legacy software is actually then transcribed as text file. Text file are source code files, and these are saved in their digital format in the software heritage archive, and then as they are saved in this digital format, they are accessible from each copy of the archive. So every mirror will have the same artifacts, which are identified with the SWID, with the software heritage identifier. That's part of the first comment I've done.
Thank you so much.
Morane. And okay, we have time for the last question. Elio.
Yeah, hello. You have spoken about knowledge, and you have put side by side books, science fiction, and software. So I was wondering, the human thinks and translates his thinking in a machine language, where once that there is a big archive of softwares which is made for machines to act what humans have thought. How can we still define that knowledge a human knowledge?
Thank
you.
The $1,000,000 question, right? The last one is the most difficult.
The last question. The last question.
So when I say it's human readable, it's because source code is written in some form that the machine can't read, in the terms of can't execute. Before executing this source code, you need to compile this software, which turns the text that a human reads to zeros and ones and other things there, and it becomes a binary that a machine can easily execute, or not so easily execute, but it can execute. And this form, the last one, the binary, is not readable by the human, because it's not words on the text file. And the reason I've used science fiction or any kind of book is that for some people, source code is like a book. It's really readable. And the example of the Apollo 11 is a very good example, because you cannot now, and you don't really want to re-execute the Apollo 11 source code and relaunch the Apollo 11 mission to the moon. But the source code, when you go and read the source code, you see the instruction for the machines, which are sometimes understandable for some humans that did work on this mission or other missions with that programming language. But there's also very interesting comments, and the comments are really fun to read. So if you, I will maybe give in the chat, I don't know if I will have the time to do that, but I will give Gianni the link to that, a blog post about the Apollo 11 mission and the readable source code. And it is really an example of how source code is fun to read. And And I think well, I don't know if that answers your question, but that's what I can say about it.
Very well, very well. Well, we are at the end of this meeting and also at the end of this series of the event called Kusarigama. And as a final remarks, I would like to thank all the students who gave this so significantly contribution to the success of these initiatives. And on behalf of all of us, I want to say thank to Morane and Leah also for joining us. And we hope, really hope, that after the health emergency, we can invite you next year in PISA. So goodbye, many thanks, many thanks. Arrivederci, arrivederci. Ciao Morane.
Thank you, ciao.